Hi, everybody.
Hi. Well, it's nice to meet you all, at least some of you for the first time. I'm Locke. I'm normally an educator sitting right where you all are right now at the museum in Boston. So you'll probably see me when I'm in a lightning cage getting struck by lightning or something similar. But for the last, since the 9th or so of this month, so the last couple weeks, I've been a science communication fellow on board the Nautilus. So I am in the Solomon Islands with Megan. What have you been up to?
Hi, everybody. I'm Megan Cook. I'm the Director of Education, as you heard, but I'm sailing on this expedition as the communications lead. This is my 13th year of sailing with Nautilus all over the world, and this is a really special expedition, and we're so excited to tell you a bit about it.
Thanks so much, and Locke, thanks for bringing your museum red coat 8,000 miles with you to be there tonight.
It's only slightly wrinkled. So it had to fit in a carry-on.
I know I hinted at this, but could you just tell us where you are in the world right now and a little bit about what your experience has been like so far? How is your life different from what it was like, when you first got on board a couple of weeks ago?
Absolutely. So right now, we are actually in the waters off the coast of Guadalcanal, so in the Solomon Islands here. And that means that this whole time we've been keeping an eye on land nearby, but we're also definitely in a weird place. This is not a lot like home. Some of that is that our sleep is distinctly different. I think both of us have been feeling that today, especially because we're doing science around the clock on this expedition. So very, very different from home, but an incredible place to be in the world.
Thanks so much. And when he says science around the clock, he's also doing outreach around the clock. So you can tune in later on when you go home, and you can listen to Locke and others kind of narrate the feed of the science that's happening 24 hours a day. And Locke joined us at 9 o'clock this morning, our time, to talk to our staff and some people that are here at the museum. And now it's several hours later. So I hope you get a chance to catch up on your sleep when you have a chance to log off afterwards. Tell us a little bit about the water you're in. How deep is it? How far are you from land right now? How far are you from land at different points in the excursion that you're making?
Absolutely. So we're in Iron Bottom Sound right now, which is not actually that deep, especially with some of the capabilities that we have here on Nautilus. It's usually like less than 1,000 meters deep, but it's distinctly one of the most incredible places that we can be. So basically, we've been here, and most of our expedition has been in search of World War II plane and shipwrecks. So that's where we've been at for the most part, and it's been an exciting time.
I'd say it's actually quite unusual for a deep sea expedition to be able to see land. I keep kind of getting jump scared by seeing the islands all around. I'm used to getting on the ship and heading several hundred miles offshore. So this has been interesting. As you saw in that drone footage, the weather has been beautiful. The water has been flat, being here in confined water, but an incredibly dense site of maritime heritage sites, and a lot for us to learn even inside these 3 islands.
Well, as we'll talk about, I know you've all have made some pretty significant finds, so you've earned a little shore leave. Tell us a little bit about the shipwrecks on the ground that you're researching and what you're hoping to learn. A little bit about the objectives of the mission, how it builds on things that you've learned before in prior expeditions, and maybe a little bit about the historical context for the shipwrecks that you're exploring right now.
100%. So the Solomon Islands are quite famous for the naval campaign and the campaign of the Guadalcanal that was fought here in the Second World War. This was the first time that Allied troops against the Empire of Japan kind of made an offensive action in the Pacific theater, but it came at an incredibly high cost for all nations involved. There were 5 major naval battles, all within the confined waters here. Over 110 ships were sunk here in Iron Bottom Sound. Over 1,400 aircraft were lost here. Now, exploration of the Sound has been ongoing for about 30 years. Dr. Bob Ballard in the early 1990s came here, found about a dozen ships, but a big part of this mission is not only returning to those, because the technology has changed so much. There's so much more we can learn from ships now, and imaging them, and we'll get to talk all about the tech, and also to do the exciting work of finding new ones. So it's an important thing not only to look at these ships as their last 8 decades of history, but we're also working to understand them as they go forward. How are they changing over time? How are animals using these habitats? There's a lot to learn from a history site.
Very cool. I'm sure we'll talk a little bit more about some of the things that you found, but I'd like to focus in a little bit on the vessel that you're on and the room that you're sitting with that is surrounding you. What does it take to make the ship operate? What, people, infrastructure, how do you make it all work? And also, how does the room that you're sitting in connect you to the land and the rest of the world so that we can be in this interesting conversation thousands of miles from one another?
So absolutely. So to just give you a smidge of perspective, this is actually a live view out the back of Nautilus that you can see right now. So we are actually sitting basically on the very top. So if we switch over right here, you'll see there's kind of basically a series of containers that were remanufactured into a studio and a live streaming room and control room and center for all of this magical work. So we're sitting right in there, but in order to actually connect us to you, including connecting these robots or remotely operated vehicles to you, it takes a lot of work. For one, we have the original signals that are coming from the robots move through a tether and then another all the way back up to the ship itself. So that's how you can get some of those amazing feeds and also power to the robots. But then there's a whole extra step, which is from there, we have basically a satellite dish that is on an antenna that's on the ship itself. So that antenna can then send all of the feeds, all that we can have, to satellites, and then can bounce back, and that's how we can actually talk to you effectively in real time. So it's quite the ridiculous dance to actually be doing to pull this off.
And right over our shoulder is the control room, which we can show you another camera view of. So at any time, if you go to nautiluslive.org 24 hours a day when we're not here at the pier, there are between 8 and 12 people in that room. Now, we work a split shift. No one's supposed to work 24 hours in a row, except Locke. And so that means that we have 3 teams. So 3 ROV Hercules pilots, 3 navigators, 3 video engineers, and they rotate around in that clock. So this room is where you're actually piloting the technology, making the science observations, answering questions from the world, and having the conversation out with everyone who's tuned in.
Exactly.
Well, you sound great. Megan, let me ask you a question. You've been on this vessel for a while. Can you tell us a little bit about the history of the vessel and how have some of the communication and research sort of strategies and technologies and methods changed during the time that you've served in this role of yours?
Yeah, absolutely. We use a technology suite called Telepresence. Now, when Dr. Ballard invented Telepresence and coined the term, well over 30 years ago, it was very ooh, Telepresence. Now I like to say to kids, we're FaceTiming with robots at the bottom of the ocean. And they're kind of like, yeah, okay, of course I should be able to FaceTime with a robot at the bottom of the ocean. And then our goal is to break it back down. What does it actually take to make that happen? So as Locke mentioned, we have this really exciting whole suite of information. So I like to think about ROVs on the seafloor like a robot on a leash, like a dog on a leash. And so you are getting signals constantly from the ship, sending them up to us in the control room, and then sharing them with the world. So we actually rent a satellite in space for 6 to 9 months a year as we head out to sea. That's a thing you can do. We also are using new technologies like Starlink and like other systems to be able to share that load, because we're basically streaming full video off of the ship. Plus, we have spectacular internet for the fact that we are on a ship. We have worse internet than you would expect at home in your apartment. So there's a great balance to it about how we can use that bandwidth. But it means that we are on 7 channels of media or of social media. We stream 24 hours a day. We aim to be in the places where people are congregating so they can get excited about the process of discovery. There's still so much left to learn about our ocean.
Well, you sound amazing. I have to tell you, we've done some kind of things like this before with researchers who are underwater a lot closer to Boston, and I'm amazed by how well we are able to hear you and see you, which is fantastic. So Megan, you talked about ROVs. Can you tell us a little bit about what that is? What's a remotely operated vehicle? What's an uncrewed surface vessel? How do they get deployed? And how do you use them to find out some of the things that you talked about with respect to the objectives of the mission?
No doubt. Yeah, absolutely. So besides Locke, this is my favorite coworker on the ship right now, which is remotely operated vehicle Hercules, or HERC as we call it. This is a 4,000 meter rated vehicle. It's somewhere between the size of a Jeep and a minivan. So for your reference, for everybody parking at home, it carries with it manipulator arms, all kinds of sensors for the seafloor, sample boxes, cameras. This expedition is entirely no-touch surveys. Out of respect for these sites, we're not collecting anything. So the main tools we're using are the cameras. And you can see someone kind of tugging on the tail of Hercules there. That is the tether that connects it back together. Remotely operated vehicles are connected all the time to the ship. That means we get a few advantages. Robots don't have to eat, sleep, or go to the bathroom. So once they go to the seafloor, they can stay there. They don't run out of batteries. They don't run out of fuel. We're sending high voltage electricity to them. At the same time, we're getting video and data back. So they're a great tool. But it's really about how we can use technologies together and in combination. That's a big feature of this expedition. So we would launch this using the crane off the side of Nautilus, and then they would descend together, two robots using the buddy system working together down into the deep. So you end up with Hercules near the seafloor filming, another ROV kind of helicopter eyes in the sky above. But as I said, these technologies are trying to work together, and that's a big part of what we want to do is how can we keep making ocean exploration more efficient, be able to collect more data, to be able to empower decision makers and managers in places, or historians and stewards. So we have an uncrewed surface vessel. So this is not connected to Nautilus. You could think about this like a remote control boat. It is pre-programmed with a route that it's going to survey, and it is mapping the seafloor beneath the ship. It's sending its data also via these antennae on the top back to the team who are both on the ship Nautilus and also ashore. And so we're able to this is Drix, and Drix has really helped us find targets we want to explore more with the ROVs. So we kind of have this like scouting party and searching party out front, while at the same time we get to go up close and make those investigations.
Very cool. We'll talk a little bit more about technology in a minute, but I'm wondering, can we talk a little bit about the human power? What do humans do both topside and, do you have divers in the water at points to help support the work of these machines that are producing this amazing data and collecting, all the information that is one of the outcomes of the mission?
I think what we've learned from this is that one of the big advantages of having remotely operated vehicles is that the humans can be on the ship or on shore, a bunch of places, but they don't have to be in the water next to the robots, which is a really handy thing. So in this case, Drix occasionally will come in to get refueled, for instance. So there's a really amazing kind of pulled together collection of a command center that's actually in Honiara on shore, and a makeshift put together control center in a hotel lobby. It's fantastic. So they're actually kind of autonomously monitoring Drix as it's moving around. But they don't have to necessarily go in the water, although occasionally like Drix will come in for refueling and then, but it doesn't actually go underneath the sea. And the same story is true with when we're on Nautilus, right? Our pilots can be in the control room behind us and doing their work there. There are also ways that there can be pilots across the globe who kind of can connect in and eventually have like that extra stage of separation between the actual Nautilus, those robots, and the pilots. But what's incredible is that we don't need to worry about the humans. They are up here, and we don't have to worry about feeding the humans or keeping them safe in the same way, or all those things, right? Robots are not expendable. We love them, but they're a lot more expendable than humans would remotely ever be.
No doubt, no doubt.
I know we were talking about this morning, Locke, when you and I were talking. I know morning means nothing to you where you are right now. But knowing that the vessels that you're exploring, they were war vessels and they have things like munitions on them. Why is it important that you be able to use these machines so that we can make sure that we account for the fact that we don't really know what's on these vessels?
Yeah, I think part of what we were learning, like even when you first land in Honiara, like one of the first signs you see is here's what an unexploded ordnance looks like. Don't touch it, don't approach it, stay on the paths that we're used to. And we're fully aware and expecting when we're going down to these wrecks that there will be unexploded ordnance nearby. And we found them many times. So it's one of the many reasons why keeping a really safe distance, even between a robot and these wrecks, is especially important. So it's something you have to keep in mind for across the board.
Definitely.
Very cool. Just want to remind the audience, you can send in questions using Slido and that code Nautilus Live. I see some questions coming in already. Could the two of you talk a little bit about the mapping and the data processing that happens with the ROVs and some of the work I know that you're also doing from the ship via sonar? How do these maps get produced and what happens to them after you make them?
Yeah, so you could think about the mapping happening at kind of a couple different scales. With a sonar, you get to choose the frequency of sound that you want that a sonar is built to emit, and also how much water is between your sonar and the thing that you want to image. Those are kind of the two main factors, the variables you could slide back and forth that would end up with how much resolution you'd get. So DRIX, as a surface vessel, is up on the top of the water, and it is collecting really great maps of the seafloor. But we've decided to one-up that and put a sonar onto ROV Hercules to be able to get those images even closer. And this is called an orbit mapping sonar. You want to talk about it?
Yeah, it's incredible. So effectively, our process is you'll find a potential site that we think looks like it could be a ship. That's looking in the maps that we've created from DRIX, that surface vessel. And then once our ROVs, our robots, are in the water and much closer to where this wreck could be, we'll start with Hercules actually effectively mapping the seafloor again, but with sonar, which is we call it an orbit. And you can see here in these images that they're basically doing a single slice, kind of like a fan as it goes across. And as you move further along, you'll get a lot more of the intricacies of what you're looking at. So you will probably be able to figure out if you think this is a ship. But also, since your robots are tethered, anything that's coming out of the ship that you might need to be worried about will be officially imaged. So you can even on the map say, right here, we think there's a potential obstacle that we need to be careful of.
Yeah, you're gonna have a really bad day. Because the robots are on leashes, we don't want to tie that leash around anything on the seafloor. It's one of the biggest dangers of remotely operated vehicles. So the Norbit produces amazing data, which we then can visually survey. So we'll be able to tie these super detailed acoustic maps, sound generated sonar maps, to the ultra high resolution images coming off the ROV to make these three-dimensional models in the end. That happens in the days, weeks, and months likely after the expedition, but they'll all be available on Nautilus Live.
Which is so incredible. Like, these are going to be more detailed than has ever been created of these wrecks.
Fascinating. And, I'm sure that there's times you find things that you want to consult with other scientists about, and science is kind of a team sport nowadays. Oh, yeah. When you find something as you have, and as we'll talk about, in the last few days, how do you sort of get people together to think about what those findings mean? Who do you have on board? And then who do you have sort of like not on board that can be brought in and phoned in to help you think a little bit about the scientific and historical context and give you advice and guidance on the kinds of things that you're finding with these ROVs and other kinds of vehicles?
Yeah.
You want to start?
I'll start and then you can finish that one. So what's amazing is Nautilus is incredibly well equipped with preparation. So before we're even going to be doing these dives, when we're finding out what the expedition is, we're already collecting a bunch of scientists, some of which are actually on the ship. So that can be scientists, that can be historical, archaeologists, things like this. So it's a massive collaboration between a bunch of countries, but also same exact collaboration is going across the entire world because we have a bunch of scientists at home. And I think the best way to describe this is that we promise not to put them on camera. And that is why we can wake them up at any hour of the night to ask a question so they can hop on. And that even happened. We had one of our scientists at home from Hawaii who actually was looking at the footage as we were watching and live streaming and was like, I think we found a bell. You didn't see it, but I think there's a bell right here on top of these torpedo launchers. And that's exactly what happened, right? It's impossible to do this work without a massive team surrounding us, both on ship and on shore.
Yeah, and just to put some numbers to it, there are several hundred experts who have agreed to watch Nautilus Live along with us and help contribute their knowledge. And it's turned out in real discoveries. This is the shipwreck, the Japanese destroyer Terazuki. This is a brand new discovery from this expedition. It was mapped by DRIX, investigated by the ROVs, but we didn't know what ship it was. No one had ever recorded this location. No one knew there was a wreck here in this place. But how do you figure out what ship it is and what are those details? And it starts in this big detective work. You start off by saying okay, based on the placement of the turrets, the number of the guns, the shape of the bow, we're pretty sure it's a Japanese ship. Then we narrowed it into being an Akatsuki-class destroyer, which was kind of a specific build of destroyers. Then our experts ashore helped us dig into the historic archive. All of this is happening in real time, mind you.
Wow, we're live streaming.
Yep, there were only 2 Akatsuki-class destroyers that ever fought in the Battle of Solomon Islands, in the Solomon Islands campaign. One was found in 2019 by a different team of explorers, which matched its historic location far to the west of where we were. So the only ship left that it could be was Terazuki. But seeing these things can also rewrite the history. So we pulled from the history books to get this the discovery, but also went back to the history books. The story of this sinking was that the depth charges were thought to have exploded and sunk the ship on the stern. We found the stern of Terazuki separated by several hundred meters from the rest of the hull, and the depth charges were still in the racks, like sitting right up on the edge of the stern. And that means it was actually a torpedo hit. That helps tell us these things, that certainly as you're experiencing the just very candidly, the horrors of war, the trauma of this experience, all these battles were fought in the dead of the night in the Solomon Islands, in complete darkness. It would be very hard to make an after-action accurate reporting. And so we can both help restore some of the details of these stories that were lost and understand how these ships sit now on the seafloor.
Thank you so much. I'm going to start going to audience questions in a moment. Mark, can I call you up, grab a microphone, and oh, he's already got one. Fantastic. I'm going to phone a friend right now. So this is Mark Patterson. He is an aquanaut. If you want to know what that is, you can talk to him after the formal program is over. But the reason I thought Professor Patterson would be good to bring in is that I know that you build and use the kinds of remotely operated vehicles and autonomous vehicles that the Nautilus folks are employing. But you use it for other kinds of research. Can you talk a little bit about how you do that and what you're learning, hearing from these folks who are using it for archaeology on these maritime ships from World War II?
Well, first of all, I'm very envious of you two being on the Nautilus. I had the pleasure to be on board when it was at dock once. And I worked with Bob 25 years ago on the Jason project, so give him my best wishes. He actually encouraged me to bring a robot into an underwater space station called Aquarius down in Florida back in the day. But to answer your question, David, I use robots to investigate the health of the oceans. In particular, how are things changing in environments like coral reefs? There are beautiful coral reefs there in the Solomon Islands that are potentially holding the cure for cancer, for new antibiotics. The people that live in the islands depend on the coral reefs for the protein from the fishes they catch. But we don't have good, cost-efficient tools to look at the health of big ecosystems like that. And that's where robots come in. I think it was Megan mentioned, or maybe it was Locke, that robots don't get tired and they can keep working 24/7. So when I've used them, David, I've often sent them out for a full day of work measuring the oxygen, the pH, the plankton. In the Antarctic, we had them count the krill that all the marine mammals and penguins depend on for food. So we use them as a same way that you fetch data back up your cable. I actually call my robot Fetch because I hoped, like a good dog, it would go out in the ocean and bring me back some cool data.
And, I asked Megan a little bit about sort of how the strategies and methods have matured during the technology as she has spent a lot of time. I know you've been doing this for quite some time too. How have some of the new technologies that these folks have been talking about make the mission different from the kind of stuff that you've done, either talking with Bob about underwater archaeology 20 to 25 years ago, or things that you are able to do that just weren't available with robotics, say, 10, 15 years ago, and the ability to process data, collect data, and really leverage what these robots can do nowadays?
There's been some significant changes in the imagers and the sensors that robots can carry now. We can build up three-dimensional maps from video imagery or from high-frequency sonar very quickly. This was very arduous and labor intensive and not so good a couple of decades ago. Now there are established workflows, and computers have gotten faster, for example. We've got sensors for things that we didn't know were going to be a problem 20 years ago, like microplastics. Probably the thing that makes me most excited, and I know this is happening with the data that the Nautilus folks are gathering, is that we can leverage artificial intelligence and machine learning to make sense of this fire hose of data that these robots are bringing back to us. To use the Antarctic example I mentioned with krill, we actually trained something called a neural network how to recognize what a krill looks like on a high-frequency sonar. And now we've got a way to quickly measure krill stocks. And in the past, that would be a very labor-intensive process. You might even have to throw a net over the side and catch the krill to count them.
Thank you so much. I think this was a really nice transition then to ask Megan and Locke a little bit about some of the things that you may have seen in the marine environment, aside from the archaeological work that you're really there to do. A lot of questions coming from our audience about, have you been seeing animals? What kinds of things have you really been noticing in the ocean aside from what you've been looking for? Anything really cool you want to show us?
We got lots of cool ones. I'll just share two really short stories, and then maybe Megan can show you some of the amazing animals under the ocean too. Because just last night, apparently, we had a whale that decided to swim alongside Nautilus, which
This is what happens when you go to sleep.
she should have gone to sleep. But that was incredible. So apparently, we saw like the blowhole, and was just like, oh my gosh.
You also had the spinner dolphins. Also did not see the spinner dolphins.
I didn't see those. I was there, and apparently we caught the footage of them like swimming behind the ship, but nothing. We think they were probably curious about some of the lights that were coming nearby. But so there's lots of animals that are on the surface. There was even some incredible birds that were just circling the ship and like kept trying to fly right by my face. So we have lots of those, but there are also some amazing underwater creatures as well.
Definitely. I think one of the things that's most exciting, I am a biologist and ecologist by training, is shipwrecks provide this really interesting laboratory type environment because you know the exact date that a ship sank. You know that any animal living on it could be no older than exactly that date. So you can start to say things about how fast communities grow, how fast individual animals grow. What you're looking at here is the bow of the USS New Orleans. That ship did not sink, but its bow and 1/3 of the ship's length was broken off in this attack, and that had never been found before, but we found it. It's laying on its side, so you're looking sort of from the water line up and to the left, up to the front of the bow. But what is growing on it are black corals. These are deep sea corals that grow really slowly, but also as you look there are anemones, there are fish, there are brittle stars, there are crabs, there are all kinds of animals that are making their home there. There are also, unfortunately, some single-use plastics in that picture. So we're seeing historic archaeology, human impacts to this place. We're seeing modern impacts to this place. But some really incredible creatures so far. Do you want to talk about the sea cucumbers?
Oh my gosh. So a few expeditions ago when they were in Guam, I was like following along, and one of the things that was really exciting for everyone was what's called a headless chicken monster. And I think maybe if you see this footage, you'll understand why it's a headless chicken monster. But this is a sea cucumber, and we happen to see one as well on one of my watches, which I feel like our watch is completely spoiled. We got all the good things, but so these are incredible creatures, and it's incredible, especially to see how they move. Right, you can like see them slowly stretch. So 10 out of 10 would see a sea cucumber again, especially a headless chicken monster.
Yeah, you can see the lasers on that. Those are scaling lasers. One of the challenges of remotely operated vehicles, and where we're now starting to see technologies like VR and 3D really come into this space, is you're just looking at a monitor and trying to make a two-dimensional display into a three-dimensional world. And so the scaling lasers are always 10 centimeters apart, which is about the width of your hand. So that chicken monster is probably about that wide and maybe about that tall. So you could hold a headless chicken monster in your hands, bigger than a softball, smaller than a volleyball, something like that. And it helps us make sense if you're looking at something tiny far away or big up close. You can really figure that out.
I'm always shocked by how often I am wrong when I'm guessing how big they are before we put the lasers on. We were looking at, I think it was like some form of jelly, and it was floating in front of us, and I was like, oh man, can we get some lasers? And I thought it was huge, and it was, number one, tiny, but we found this out because when the lasers moved, it suddenly got into the surface and just lit up the thing like it was a Christmas tree. So it's incredible, and seeing that it was that incredible, like it couldn't even have both of the lasers on at the same time, so it was less than 10 centimeters across. It's tiny jelly.
So, Megan, you brought up the marine debris that we saw in that picture, and as somebody who spends a lot of time thinking about how we communicate what you're finding with the public, and I if any of you want to, you can go home when this program is over. You can watch Nautilus all the time, and you can see the comments. And a lot of people are asking questions and making observations, both about animals that you may or may not be able to see in real time, that they see whizzing by, as well as some of the single-use plastics or other kind of marine debris that are visible in some of these pictures. What are you seeing as somebody who spends a lot of time on this vessel, and how do you use these moments as a window into teaching people about marine ecology and environmental conservation?
Absolutely. I'll hit you with the sad truth first. The sad truth is everywhere we've gone in the world's ocean, even the deep ocean, we've found our trash has gotten there before our cameras have. So there is no place on Earth that our stuff is not. But the good news is we can do something about it. My favorite trash intervention is a googly-eyed solar-powered trash collector that is on the East Coast near you called Mr. Trash Wheel that has a whole internet personality. But the point of Mr. Trash Wheel is that it catches stuff in streams, in rivers, before it gets to the harbor, before it gets to the ocean. Once things are in the ocean, they're very, very difficult to clean up and to clean up completely. But managing our trash in a responsible way is the way that we can turn off this spout of debris getting into the ocean. I think these things are really exciting, and the wonder of it, the shock of it, all of those are moments where people can be empowered and engaged. There are 50 people on Nautilus at a time. Very few of them are marine biologists. Very few of them have PhDs. This work, as you said, is a team sport. You could be an engineer, you could be an artist, you could be a filmmaker, you could be a computer scientist, you could be a chef, you could be a captain. The chefs, frankly, are the most important people on this entire ship and the hardest working. So, I like to say that our passions in life should be kind of a Venn diagram. And I hear a lot from people that are like, oh, I wanted to be a marine biologist once, but now I do something else. And you're like, you can love the ocean, you can love science, you can do good for this world in whatever the rest of your passions are. So I'm just in the game of wanting to put a little circle that says ocean into everybody's Venn diagram. Be an accountant, be a community organizer. Any of the things you're passionate about can take steps towards helping us understand this planet and take care of this planet.
Thank you so much. Mark, let me ask you a question really quickly, too, as somebody who spends a lot of time living and working under the water. And again, you can ask him more about that at the little table that he has. What are the kinds of changes that you've seen in your career as somebody who spends a lot of time under the water, not just marine debris, but other kinds of changes that we're seeing, and what this means as someone who's documenting the health of organisms under the water as an environmental engineer and as a marine biologist?
So I like to tell my students, I didn't start off thinking I was going to be a global change biologist, but now I am, because of everybody on Earth, where, we're all in this together and we're all changing the planet in profound ways. I was inspired by Jacques Cousteau back in the day to become a marine scientist, a marine biologist. And it was his television shows that captivated me, that biology really grabbed me. And I had a formative experience when I was the age of a lot of the kids here in the audience, where I got to see a coral reef for the first time. So I started off being a coral reef biologist, and it's been very painful over my career to watch this major ecosystem, which may become the first ecosystem to collapse at our hands, suffer the way it is. That said, I'm an optimist, and I try and look for ways that we can use these new tools. We are in the golden age of tools and toys and software like you've got on the Nautilus there. we can use these tools to get a view of our planet that previous generations of marine scientists have never had. The ocean has always changed faster than we've had the ability to observe until now. And this gives me hope that we can find a path to some solutions for some of these pressing environmental problems.
Thanks so much, Mark.
Is so
and you'll have
right.
a chance to talk to him.
There's never been a better time to be an explorer than right now.
Truly.
And you'll have a chance to talk to Mark a little bit later at his station. This point you make about tools, and Megan talked about it too, I'm going to start to get to some of the, we've already gotten to some of the questions, but here's a kind of a slightly technical one, but I think you'll be able to talk about why this is such a good question, especially Megan. One of the persons says, in addition to the cameras and the sonar, are you also using bathymetric LiDAR in the processing? And I think the answer to this is yes. Can you talk a little bit, Megan and Locke, about it and what that teaches you?
Yeah, great question. Sounds like we got some technology experts in the room. LiDAR for everyone is a laser scanning. So, when we think about using acoustics to map, you could think about this being very much borrowed from the technology of nature, like echolocation with bats or dolphins. You are sending sound down to the seafloor. It's bouncing back. You can measure very precisely the amount of time between when the sound left and it came back, and measuring that time and knowing the speed of sound in water tells you the distance away. LiDAR is using lasers. It's using visual light to do the same. LiDAR is flown by airplanes and helicopters and drones on most of the kind of dry and dusty parts of Earth. And you can get ultra super precise maps of the seafloor. Now, LiDAR can be used in shallow water where the light can penetrate, but there's a bit of a problem that's just the physics. And that is that light scatters quite quickly in water. That's why things kind of change color. It's why the ocean is dark as you go down, is that all of the energy from the sun, all that light, is scattered away as you start to get deeper. So we're primarily using acoustics because we can send from Hercules to the shipwrecks. We're flying 150 feet at least above the ship. So we are far beyond where we can see with our lights when we are making those maps with the Norbit. And then we get closer and shine the lights on them. So we primarily use acoustics rather than LiDAR, but there are some really cool technologies for flying drones in shallow water, especially in tropical waters like here, where the water's quite clear, that you can get that ultra high resolution down into the shallow coral environment, even down into some of the reef slope using, again, playing with those levers of the frequencies that you use of light and some of those other tools. So it is, if that is your passion, that is a huge field opening up for you, and absolutely go and do it.
Yeah. And I would say that Drix actually does have a LiDAR, but not for under the sea, just for finding local objects that might be nearby, right? So object detection. And I know that there's a robot probably right next to all of you right now, which is Spot the robot dog from Boston Dynamics. And some of our other robots too also use similar tools. So LiDAR is definitely at home and here.
Yeah, thanks, Locke. There's a question actually about Drix. Someone wants to know how detailed the images that Drix creates are. For example, can you identify the type of ship just from the images that it gives you, or do you need to sort of cross-reference with the other kinds of data that you're receiving so that you really understand what you're looking at?
It's a great question, and it all matters how deep the water is. If Drix is running in shallower water, you get less coverage, so less width, but more detail. Some of these targets are quite clear. The USS Northampton was a ship that was known. It is on a flat seafloor, we have learned here in Iron Bottom Sound. So a big ship like Northampton pops right up out of the bathymetry. We look at both the bathymetry, which is the depth of the water, so you could see it gets shallower above the ship and then deeper on the other side. We also look at the backscatter, which is, you could say, is like the echoiness of the sound coming back. So sometimes we can see these in one or the other. Here's another, the Royal Australian Navy's HMAS Canberra on flat seafloor, very clear. But here's a different one. This was not, I would say, a crystal clear target. Some of the things we've identified by being able to look literally on a map, we've triangulated the positions, last known position the Navy thinks this sunk, position other researchers think they've sunk, and we end up with this like dartboard scatter shot of where the region-ish we think some of these ships are in. Then if we end up with a Drix target, even if it's like maybe sort of barely something, we could say, we're constantly ranking this list. This seems like one we should investigate next. Oh, that's probably a geologic outcropping, maybe a really cool rock or some part of a cliff. And there's many more targets than we've been able to investigate so far. So everyone already is angling for another expedition to get to come back here and to get to see more and more of these targets.
I remember when I was in the control room with all the amazing University of New Hampshire Drix kind of control officers and folks. One of my favorite moments was how I would point and be like, that definitely isn't a ship. And they're like, no, that's the ship. That one's confirmed. I'm like, oh. And then I'd be like, that one's a ship. They're like, absolutely not. No way. So it's the opposite of what you expect. So it's a really specific kind of set of skills. And also, that's kind of why some of the historical record can come in such a key part, right? It adds to that so that you know which ones to investigate.
Total teamwork.
So we have a really good question here about sort of how you land on the missions that you do. Someone asks, how do you decide which geographic areas to do research in, and what does it take to then be able to go to the places that you're dreaming up?
Oh man, so much work in advance. So this is Nautilus's 173rd expedition around the world. When we first acquired the ship, it was in the Black Sea, the Mediterranean, the Aegean. It's been in the Atlantic, the Caribbean, the Gulf of Mexico, the Pacific from Ecuador to Alaska, all the way across the Central Pacific, and now out here to the Western Pacific and the Solomon Islands. Some of it has to do with who's funding it. This expedition is funded by NOAA Ocean Exploration, a federal agency, through a group called the Ocean Exploration Cooperative Institute, which you could think about a little like a think tank trying to improve the efficiency of ocean exploration, just what Mark talked about. So that's what brings multiple partners together. OET with the ship and the ROVs, the University of New Hampshire with Drix, the University of Rhode Island helping us with the broadcasting. So we kind of get an expedition funded. Every year, we have many more things than we would get funded, and we go into these meetings and we sort of slide a list across the table, and they slide a list across the table of priorities, and we pitch some and they pitch some, and you start to want to build a schedule where it's efficient. You don't want to be like bing-bonging here to there. Ships don't move particularly fast. You could go downhill on a bicycle faster than we usually drive our ship. You could beat us in a race on a short distance for sure.
And be less seasick.
Yes. And so that's part of the priority. And then once you decide on a location, you start to build the team. That's where we have archaeologists and historians, experts from all former combatant nations as part of this. But this expedition's been being built for almost a year and a half. And we do 6 to 12 of these a year. So we're kind of constantly pushing out, where do we want to go next? Their point being 27%. Just over 1/4 of the world's ocean is mapped in high resolution, and the percentage that humans have actually seen is much less than 1% with a camera or our own human eyes. So we will never run out of work to do. We just try to be efficient, going places where the data we collect can be in service to the communities that live near these oceans and afar, help them manage and take good care of their ocean, help all of us make better decisions about the ocean, help us understand things that, this is just the start of the process. There will be people examining this data for weeks, months, years, decades afterwards. All the data is publicly shared in that way. So, we want to be in best service to the community and how we can learn about the ocean.
Thank you so much. I know you're busy, so we only have 2 more questions before we need to let them get back to their actual work. One of them will be easy to answer, and it'll be at the end. The really good question here, someone wants to know about whether the wrecks cause any concerns about the marine environment. Do they impact water quality? And specifically, they're interested in knowing if Hercules takes water samples, and if not, how you find out what the water is like around you, knowing that you are not sending divers down.
Yeah. I can take a crack at that. In the research, they call this PPW, potentially polluting wrecks. As we know, there were 17,000 ships sunk in the Second World War that are now 80 plus years old on the bottom of the ocean. The basics of chemistry tell us that things are corroding and rusting in a salty environment. So we know these wrecks are changing. A big part of this expedition and building those 3-dimensional models is to get a baseline for many of these. As I said, we aren't doing any interventions. We're not touching or disturbing these wrecks, but we do know that many of them sunk with ordnance, with fuel oil, with these things that could really harm the marine environment. So this data being shared with groups like the US Navy, archaeologists in Japan, local Solomon Islands government, give them the tools to understand these. It's very interesting also, since some were found 30 years ago, we're already seeing major change. The Japanese ship Udachi, we almost didn't recognize her. Our historians got down on the wreck and we were actually a bit disoriented because the drawings and details from 1992, when we saw it now, major structures had collapsed, masts had collapsed, the bridge had fallen. And so we know they're changing. And so this is really important to get that data. There are interventions, not here in the Solomons, but across the Western Pacific that have been done to pull oil, pull fuel, pull ordnance off of ships that were in danger of hurting coral reefs and hurting the communities who rely on these healthy environments. So things like that can be done, and our data will be a bit part of understanding that. Nautilus or Hercules can collect water samples. We're certainly collecting conductivity, salinity, understanding the currents on the seafloor around these environments. Currents can really change corrosion, which blew my mind learning that from a chemist, that the more water going by something, the more chemical reactions you're going to have between the metal and the water. So like high current ships are in danger potentially of corroding faster, but also if you cover that with marine life, they get like a safety blanket. So there's all these forces, levers, pushes, and pulls on how they change.
And that's one of the reasons why all the wrecks that we saw, even though they were sunk around the same period in time, the actual state of these wrecks in terms of decomposition, in terms of rust and changes to those structures, is just completely different for each one. So it was a completely different picture from wreck to wreck.
Thanks so much. And Megan, you just answered one of the other questions I didn't think we were able to get to, which is, why can't we just pull these things up and stick them in a museum? I think you've done a great job of explaining that. That means I can get to the two final questions, and I'm going to ask them together. You'll understand why. One of them, I'd love your answer to both these, is what's the most exciting or surprising thing that you've seen on this expedition? And then the other one is, does the ship have a cat?
Oh, I wish. I think we all wish.
I don't have a golden retriever, but it's okay.
Oh my gosh.
What's the most exciting thing, Locke?
Oh man, there have been so many exciting things. I think more personally for me, the exciting moments were when I was being taught or like given the opportunity to do something that was completely brand new to me. So we have not only Hercules, but there's a little ROV called Little Hercules that I was able to help with just a little bit of work. And that was just like kind of a highlight for me because, you spend a lot of your life, and, I grew up on a farm, all these things, like you think that you're handy and then you come to a world like this and you're like, oh my gosh, that was the most frustrating thing in the world. But I'm so proud and so grateful to have been able to get through that. So I think those are some like personal moments. But I think the wrecks just generally like hit again and again. Yeah,
absolutely. Here's Locke on the back deck helping with the launch of ROV Hercules. So
this was also the best moment ever.
Yeah, so,
I think I danced more than I should have.
Yeah, definitely. No one is a passenger on Nautilus. Everybody is a part of the work. I think one of the things that's been really special for me is, I'm the granddaughter of naval aviators, and I think one of the stories of sharing these wreck sites and this exploration with military service members, family members that are remembering these. We have all these people that are writing in and telling us stories, writing in and remembering these. So it's a real combination between like there's an excitement to this work and there's a solemnness at the same time. Almost every one of these ships are war graves, and part of why they won't be disturbed and will always be respected is for that. And so it's this real blend to be able to bring some closure, some community across international nations of former combatants, and to be able to like tell those stories together, I think is really, really powerful. My most exciting is definitely the USS New Orleans, because I got to, again, I'm a coral reef ecologist turned deep sea science communicator, and I was like, I am a detective. When we found this ship, I woke up at 3 o'clock in the morning to talk with some kids here in the classroom, and over my shoulder, I see the team come upon this wreck. And I'm like, what is this? And I tune in, I switch the channels on my headset, and I'm listening to the team, and they're kind of sorting through, like, we're not sure what we're seeing. We're just, let me see, like, let's see if we can put it together. And they're zooming and they're looking at different parts of the ship. And we're process of elimination. You know, this isn't a whole ship. It's just a bow. It's just part of a ship. Where's the rest of it? We find the anchor. We zoom in on the anchor. There's writing on the anchor. And it says USS Navy Yard. And we're like, okay, it's a US ship. This is the bottom of the anchor. And you're like, okay, all right, what US ships lost half of a ship or part of a ship? And you're in this total detective mode. Here you can see some letters. We're guessing. We're like, does it say 10? No, it's upside down. And we came off of watch. And one of our historians woke up and came in to find me. You know that meme that has the string and all the photos connected together? That was me. I was like, come here, Frank, I need to show you this picture. And soon we pulled up this historic photo. This is the USS New Orleans in a dry dock in 1936. And we found a couple really specific details. The collaring around the anchor, the little notch that's right here in the bow in the center, the shape and measurement of the bow to the waterline. And we were able to say for the very first time that we had discovered USS New Orleans, which is also an incredible story in and of itself. A third of this ship was blown off and the ship did not sink. Thanks to the heroism of the team aboard, there were many members of their team lost, and yet the entire ship, which frankly had no business being able to still float in this condition, it had to be driven backwards from the Solomon Islands to Australia in order to get repairs. And then they partially repaired it and sent it back to Washington State in the US. But the repairs didn't work, so they drove it backwards from Australia back to the US. So to be able, that ship after the war was melted down. USS New Orleans, the ship is no longer around. The bell is in the city of New Orleans. And so the only other remaining piece was found on the seafloor. And, I didn't really know how that happened. And my like string map harebrained, like, look at this picture next to this picture, look at this next to this. And we got to send it to the US Navy and they said, like, that's it. Yep, that's it.
Right.
And I was like, wow. And then my job takes back over. You get to write the press release, you get to run the social media video, you get to help share it with the world.
It's incredible.
Maybe you all have already known about this, but if not, I encourage you to go home and search for the story that Megan is talking about. Both of the finds that Locke and Megan mentioned have been all over the news the last week and a half. Really interesting stories. And I just want to say before we say goodbye to our wonderful science communicators, there are ways for you to keep this sort of following this story. What's really cool about the Nautilus EV is that you can actually watch their feed anytime. And you can be one of the people that's sort of looking and commenting and asking questions, and sometimes they even answer. You'll hear Locke's voice or Megan's voice answering questions that they hear as they go. And Locke is amazing. He really has not slept very much since he got on board, because in addition to narrating the feed and doing the kinds of work that he and Megan have been talking about, he's also been writing for the museum's weekly environmental newsletter. So you can read some of his accounts if you want to about what it's been like to do some of this amazing stuff. So I want to say thank you so much, Megan and Locke, and pleased to pass our thanks along to the entire Nautilus team. It's really cool, and I don't know if they'll hear this or not, but can you all give them a big cheer and a round of applause?
Yeah, kudos to you all for showing up. Thank you for being curious about the ocean and wanting to keep learning about this amazing world that's out here. We hope you'll explore with us more, and you'll have Locke back home soon to tell all the stories. So keep coming back to the museum and interacting with the amazing team there.